The overall concept in acoustical construction is to have your room floating within the current structure. Any connection to the existing structure is called an acoustic short circuit. This type of short circuit can be caused by as little as one misplaced screw. So it's important at every step to avoid as much contact with the existing structure as possible. Where contact is inevitable, we'll try to minimize the effect by using isolating mechanisms such as neoprene or resilient channel. These contribute to the decoupling effect. To decouple means to separate or detach. In my project, maximum isolation is not the goal. My goal is to design a proper listening environment. The negative effects of my project is that I'll never be able to track loud bass and drums in the middle of the night. C'est la vie! If you need maximum acoustic isolation for your project, refer to practicalstudioconstruction.com for a list of professional vendors who provide serious isolation products. You want to slant the ceiling a bit so it will not be parallel to the floor. The angle that I ended up with was determined by the process. As you can see here in my model, the support beams for the house is a force to be reckoned with. The idea would be to slant the ceiling into the beam and then continue that angle on the other side. But what angle is that to be? It just so happens that the measurement from the back wall to support beam was a little over 10 feet. It occurred to me if I split a 2x4 diagonally that would give me a gentle angle and would also be easy to measure. Splitting a 2x4 in half diagonally forms a right angle triangle. We want to find the angle shown here. The relationship is as follows. The tangent of the angle is equal to the ratio of the length of the opposite side to the length of the adjacent side. My 2x4 is 3.5 inches tall and 10 feet wide, so that's 3.5 inches divided by 120 inches, which is 0.029. The arctangent of that number is 1.67, which is the angle we want to find. If you have a table saw that would allow you to rip these 2x4s safely, then use that tool. I didn't have that, so I built a jig to raise them off the floor so I could cut them with a circular saw. We need to mark a line on which to cut. To do this, place a nail at one end on the corner of the jig, attach a chalk line reel to the nail, and pull it to the opposite corner. Hold taut and snap. This gives you a blue chalk line on which to cut. Set the blade of the circular saw so it's deep enough to cut through the wood, but not so deep that it goes into the floor. This is why we suspended the 2x4s with the jig. Once that's set, then you're ready to make the cut. In order to facilitate installation of these pieces, it pays to pre-drill the holes for the screws and to start the screws in the wood so that the tip of the screw is just starting to peek out the other side. If you're working by yourself or with another person, this makes the installation a lot quicker. Start at the thickest end and drill a guide hole for the screw. The bit to use should just be slightly smaller than the screw itself. Drill the first hole and then make another hole every 16 inches or so. Now that all the pieces are ready, we can start the install. I chose to put the thickest end of the 2x4 in place first, since that was the most critical placement. In my situation, I needed to clear a water pipe, and that water pipe was parallel to the support beam, so it made for an excellent guide. When it's all said and done, you can see that we have a nice 1.67 degree angle that will slant the ceiling from the back wall of the control room towards the main support beam for the existing structure. If the water pipe had not been there, I would still want to put some sort of a gap, maybe a 1/4 inch or so, between the angled wood and the main beam to contribute to the decoupling effect. Now we need to continue the ceiling support on the other side of the main beam. This is a bit tricky in that the ceiling needs to hang from the house joists and continue the same angle. The plan will be to attach a 2x4 to the main beam, but place a thick piece of neoprene between the 2x4s and the beam for the isolation. Then, using strong tie brackets, we can hang the ceiling frame from the joists. Additional support will be had when the walls are built, as the ceiling will lay on top of the wall frame here. From our design, we have a good idea where the front wall of the control room will be, so we can place a chalk line on the floor where that wall might be and use that as a guide for the ceiling. Using the chalk line reel as a plumb bob, we can hover over our line on the floor and mark the spot on the ceiling to place the hangers. If you do this on both sides, you can use a piece of string to make a guide on the ceiling to install all the hangers. Using a right-angled tool, we can align all the strong tie hangers and fasten with drywall screws. Make sure they are installed identically so the ceiling will be level. As far as attaching the 2x4s to the house beam, we'll use a section of neoprene. Neoprene provides a certain amount of acoustic isolation between two surfaces. Yes, there will be screws that will go through the 2x4, the neoprene, and into the main beam. And this will be an acoustic short circuit and should be avoided if maximum acoustic isolation is needed. The neoprene in this install is used to contribute to the decoupling effect. The bulk of my decoupling will come from the resilient channel used to hang the drywall later. So we lay out the neoprene and cut it to the length of our 2x4. Again, we pre-drill the holes and start the screws. This time we want to go all the way through the neoprene so it won't slip out of place when we attach the beam. When you install the 2x4, double check that it's level and everything should be good. Now we need to cut the angle for each 2x4 we will hang. We know our angle is 1.67, but it pays to put each 2x4 in place and mark the actual angle with the angle tool and then trim off the ends. We used a strong tie perpendicular hanger for this job, which allowed us to build the ceiling in place. An alternative would be to build the ceiling on the floor and then raise the whole ceiling into place. I thought that might be a pain, so I opted for this easier solution. You just attach the hanger to the support beam, then place the cross 2x4 in the hanger and screw it into place on the sides. Then attach it to the hangers on the other end. Double check your level as you go. I've mentioned resilient channel before. We'll call it RC from here on out. This is the way we're going to hang our drywall onto the ceiling joist to decouple it from the main structure of the house. RC works sort of like a hinge or a spring. It will give or allow the wall to move without transferring the energy to the stud-work that it's attached to. These are attached perpendicular to the stud-work and are placed 2 feet apart. Place a screw through the RC and into the stud and you're done. Drywall panels are 8 feet long, so by placing the RC 2 feet apart, you will have proper support on the edges of each drywall piece. To join 2 pieces, you cut the first piece with tin snips and then nestle the second piece under the first piece and screw through the whole thing. Once you've installed the RC lattice work, it's time to hang the drywall. Before you start hanging drywall, it pays to mark where your ceiling joists are and where the RC is so that you can put the screws in the right place. We took a can of black spray paint and made marks on one wall where the framework is and on another wall where the RC is. The idea is to put the screws so that they go through the drywall and the RC, but not into the frame. By marking the placement, you can be assured that the screw is in between the framing. It may also help to draw straight lines on the drywall itself to help you hit the RC each time. When you've installed each screw correctly, it looks like this. So now it goes through the drywall and the RC, but not into the frame. Sealing drywall is much easier with 2 or more people. The ceiling height in this space is 9 feet, so we need to work on ladders. To help hold things in place, we built a support cross out of 2 pieces of 2x4, which helps hold one end of the drywall up while you wrangle your ladders into place. Now, as you can see, the ceiling is finished and it has the proper slope. Now let's build the subfloor.